Hello everyone, my name is Umang Pratap Singh and I'll be teaching you mathematics of class 9th. So today we are going to start chapter number 2 of polynomials. Okay, so before I start this lecture, let us see what are the topics which we are going to cover. So the first will be the introduction of this chapter. Second will be the polynomials in one variable where we will discuss about the definition of the polynomials and what are the polynomials in one variable. Okay, after that, we will see what are the zeros of a polynomial, then remainder theorem, okay, which is a very important theorem for this chapter. And then we will see factorization of polynomials, then algebraic identities, which is again a very important part of this chapter, as well as in your senior classes. This topic will be very important for you. Okay, and then after that, at the last, we will see the summary of this chapter. Okay, so let's talk about the introduction. So you have already studied algebraic expression and their addition, subtraction, multiplication, and division in earlier classes. Okay, that is in 8th. And you may also recall these algebraic identities which you have studied in class 8th. Okay, and in this chapter we shall start our study with a particular type of algebraic expression called polynomial. Okay, means these are the algebraic expressions, but it is of a special kind. And what is special in it, we are going to discuss in this chapter. Okay, so we'll start with polynomials in one variable. Okay, so before I start polynomials in one variable, let us see what are variables and what is a constant. Okay, so a variable is denoted by a symbol that can take any real value. Okay, what is a variable? It is denoted by a symbol, and a variable can take any real value. Okay, that's why it is called variable, means the value which can vary. Okay, and it is denoted by any symbols. So we use the letters small x, y, z, etc. to denote the variables. Okay, so notice that this 2x, 3x, x, minus 1 upon 2x are all algebraic expressions. And right, and all these expressions are of the form, it's like a constant multiplied by a variable. Okay, in all these expressions, you can see there is a constant value and there is a variable. Okay, for example, in 2x, you can see 2 is a constant, it's a number, and x is a variable. In 3x, you can see 3 is a constant, x is a variable, and so on. Okay, now suppose we want to write an expression which is a constant multiplied by a variable, and we do not know the constant. Okay, means in these examples you are knowing the value of the constant like 2, 3, minus 1 upon 2. So if we want to write an expression where we do not know the value of the constant, so what we are going to do, we will denote these constant values as small a, small b, and small c. Okay, so in such cases we'll write constant as a, b, and c. So for example, if you want to write such expression, it will be in the form of ax, okay, or bx, or you can say ax square plus bx plus c. Okay, so here you can see this a, b, and c, this denotes a constant, right? And this a, b, c can be any real numbers, and this x square x is a variable. Okay, so I hope you understand. Now let's talk about what are polynomials. Okay, we know what are algebraic expressions. Okay, any expression is in the form of a constant multiplied by a variable. For example, a into x. Okay, or you can say ax. So it is an algebraic expression, right? Now, what are polynomials? So all the algebraic expressions that has only whole numbers as the exponents of the variable are called polynomials. Means in all those algebraic expressions where the exponent of the variable is a whole number. Okay, means the power of this variable should be a whole number. Okay, the power of this variable should be a whole number, then it is called polynomials. For example, 2x, x square plus 2, x, x cube minus x square plus 4x plus 7. In all these examples, you can see the power of the variable is always a whole number. Okay, here also this 2 is a whole number. Here x raised to power 1 is there, so it's also a whole number. Here also the exponent of the variable is always a whole number, so it is a polynomial. Okay, means if something is written as 1 upon x, it means x raised to power minus 1, and this minus 1 is not a whole number, therefore it will not come under polynomial. However, 1 upon x is an algebraic expression, but it is not a polynomial. Okay, so the power of this variable, you have to focus on the power of this variable. Okay, and if this power should be a whole number, then it is a polynomial. Okay, now let's discuss about the terms and the coefficients. Okay, means what are the terms and what are the coefficients. So in the polynomial x square plus 2x, the expressions x square and 2x are called the terms of the polynomials. Okay, means these two expressions are called the terms of the polynomial, and you can see these two are, we have divided it by like this plus sign. Okay, this plus sign divides them, means this is count as 1 and this is count as 2. So you can say there are two terms in this polynomial. In a similar way, we can say in 3y square plus 5y plus 7, there are three terms, namely 3y square, 5y and 7. Okay, so can you write the terms of this polynomial? Yeah, exactly. You can see there are four terms. Exactly. This is the first term, this is the second term, this is the third term, and this is the fourth term. Okay, so the four terms are minus x cube, 4x square, 7x, and minus 2. Okay, these are the four terms of this polynomial. So I hope you understand about the terms. Now let's discuss about the coefficient. Okay, so as you have seen, like in 2x square plus 5x, we were having two terms. Okay, and in these two terms you can see the factors of these. The first term is 2 multiplied by x multiplied by x. Okay, so here you can see we have, means you can say there are three factors. Okay, there is a constant and the variable. So this constant, or you can say the numerical factor of the term, is called the coefficient. Okay, or you can say the numerical coefficient. So let's see what are coefficient. The numerical factor of each term of a polynomial is called the coefficient. Okay, it is however called numerical coefficient, but in general term we used to say it as a coefficient. Now each term of a polynomial has a coefficient. So coefficients of x cube plus 4x square plus 7x minus 2 are. So let's write the coefficient of these terms. So the coefficients of x cube is minus 1. Okay, because the numerical value, okay, or the numerical factor is minus 1 here. The numerical factor of this second term is 4. The numerical factor of this 7x is 7, and of this constant term is minus 2. Okay, so the coefficients of these terms are minus 1, 4, 7 and minus 2. Okay, so you just have to look for the numerical factor in each term. So that numerical factor is called the coefficient. So do you know the coefficient of x in x square? So we have a question. We have to find the coefficient of x in this polynomial. Okay, so as you can see here, this is minus x, that is minus 1 into x. So the coefficient of minus x will be minus 1. Okay, now let's talk about constant and zero polynomials. So what are constant polynomials and zero polynomials? So a polynomial having its highest degree 0 is called a constant polynomial. Okay, so the highest degree is 0, it means x raised to power 0. Okay, and when there is x raised to power 0, you can see any polynomial will become a constant number, right? Means 4, 2, 3, 5. Therefore all the constants can be called as constant polynomials. So for example 2, minus 5, 7, etc. are the examples of constant polynomial. Okay, and now let's discuss about the zero polynomials. So there is a constant polynomial 0. Okay, so this constant polynomial 0 is called the zero polynomial. Okay, it is the alone, or you can say this is the only polynomial which is called a zero polynomial, right? And now if I discuss, or if I talk about the degree of these polynomials, so as you can see, the degree of a constant polynomial is x raised to power 0. Okay, so that it becomes 1 and the whole polynomial becomes a constant. And now if I talk about the degree of a zero polynomial, okay, so it is 0, and if you multiply it by any like degree of the variable, like x raised to power 2, or 0x raised to power 99, or 0x raised to power 36, okay, the final answer becomes 0. So actually we cannot exactly define the degree of this zero polynomial, because whatever the degree is there, the final answer will be 0. So the degree of a zero polynomial cannot be defined. Now we have some questions. So you have to tell, are these polynomials or not? Okay, you have to explain why these are polynomials or not. Okay, so just give me the answer. Pause this video and give me the answer. Okay, so I hope you all have done. So let me tell you, all these algebraic expressions are not polynomials. Why? Because in this first question, you can see it is x plus 1 upon x, and you know 1 upon x 1 upon x is x raised to power minus 1. Here, this is root x plus 3, and you know root x is equals to x raised to power 1 by 2. So it is x raised to power 1 by 2 plus 3. And in this third expression, it is y raised to power 1 by 3 plus y square. So now you can see here the power of this variable is minus 1. Here in this case, the power of this variable or exponent of this variable is 1 by 2, and in this case, the exponent of the variable is 1 by 3. And you can see all these three are not whole numbers, right? These are not whole numbers, therefore these are not polynomials, okay? Because we have already discussed that exponent of the variable should be a whole number, then only the algebraic expression is a polynomial. Therefore these are not polynomials, okay? So the above algebraic expression are not polynomials. Reason is, in a polynomial the exponent of the variable should be a whole number.